Hello guys, welcome back to the channel. So today we are going to cover the basic mathematics that we required for learning machine learning. So in this video we will learn the basic mathematics. We are not going to do any mathematic numerical or something. We basically learn how what numbers are, what variables are, how function work and how Python replace pen paper mathematics. Okay. So let's start. We will go from like basic to advanced. So in this video we are basically cover the very basics. So let's begin. Firstly we talk about functions. What is a function? Okay, so basically it is a rule that takes an input and gives one fixed output. Okay, so basically a function is it is a rule basically that we takes an input and we get an output. Okay, let's take an example. For example, we have y that is equals to x plus 2. X plus 2. Okay, so here we can say x is variable, also y is also variable. So, and we gonna put the value of x, and we get a fixed value for particular x of y. Okay, for example, now if I take x equals to, let's take the value of x here and we will see how the value of y is generated. Okay, for x value 1 we got y value 3 because 1 plus 2 give us 3, and if I put value 2 I got 2 plus 2 4. Okay, and also in our machine learning we prefer to write f of x instead of y because it helps us in to find the derivatives and also for the better understanding in machine learning. So we prefer to write f of x instead of the y as a variable here. Okay. And the important thing that we need to remember that one input can give only one output. Okay. So let's talk about the next topic, that is continuous functions. So what are continuous functions? Okay. So continuous function, a function is continuous if its graph is smooth and unbroken. What it means, let's firstly write the definition. So function is continuous if its graph is smooth and unbroken. Okay. So it basically means if I want to draw a square, so how can I draw the square? So there can be a two method. Okay. So I can draw a square like this, 1, 2, 3, and we take 4. Okay. And the another method is like if I don't lift my pen. Okay. Like in this case, what I do, I make one line, then two line, the third line, then fourth line. But here, I didn't lift my pen until it completes. Okay. So in this case, we can say it is a continuous because we didn't break the path. But here, we are making first line, then second line, then other, then other. So it is not continuous. And if we take an example of a graphs, for example, this is a graph, and if there is any function that we're representing here, and it goes like this, so we can say it is a continuous function because there is a not breaks. But if there is another graph that is drawn like this and this, so we can say it is not a continuous function because the function does not satisfy for these values. Okay, and a continuous function is satisfied for every value, and it always have an output, single output for a particular value of x. Between any two values, is it must satisfy every number that is present between two values. For example, I am having 1 and 2. Okay, and between every value of 1 and 2, for example, there can be 1.1, 1.11, 1.1111. Okay, so and so on, definitely. So our function must satisfy for 1, 2, 1.1, 1.111, 1.111, and other values that are present between 1 and 2. Then we can say it is a continuous, else it is discontinuous. Because at some point we are getting breaks, or we can say a graph is distorted. Okay, so we can say it is uncontinuous, discontinuous, or we can say whatever, we can say discontinuous. And this is continuous graph. Let's talk what is graph. What are graphs? So graph is a visual picture of a function. Basically, it gives us a visual picture or a basic representation of our data. It shows how input x changes with output y. Okay. So we know x-axis we take as input. We take the value of x, and our output we are getting on y-axis. Okay. So if we're taking the function that is f of x equals to x plus 2, we get some points, right? For x and y. For 1, I am getting 3. For 2, I am getting 4. And for 3, I am getting 5. Okay. So let's see how we can draw the graph for this. Although it is very simple. So I have 1 here, 2 here, 3 is here. 1, 2, 3, and it is x-axis and it is y-axis. Okay, so 1, 2, 3, 4, and 5. So 0, 0, 1, 2, 3, 4, and 5. So how we represent? So 1 on x1 we are getting y as 3. On x2 I am getting y as 4. On x3 we are getting y as 5. So we can see we are getting the points, but whenever we are drawing a graph, we basically connect the points. Okay, we basically connect the points, and in this way we got the graph. So we can see we are getting a graph, and we can see there is no break. Okay, between any line. So it is a continuous graph, or we can say a smooth graph. It basically represents a continuous function. So it is returning a smooth graph with no breaks. Okay, let's talk about the Cartesian plane. Although we have studied it in our lower standards, We also call it as XY plane. Okay, so Cartesian plane is a 2D plane, 2D space that basically represent as x-axis, represents katra mein x-axis, x-axis and a y-axis. Okay, so for x-axis we can say it is a one number line going left or right, left to right or right to left. Okay, and similarly for this one we can say one number line going down, up and down, up and down. So basically this is our Cartesian plane where we have an x-axis and here we have our y-axis, and we can say it is moving from left to right, or we can also say it's moving from the right to left, and similarly y-axis is going from up to down and down to up. And in every point on graph is represented using represented as x comma y, where x represent x-axis and y represent the y-axis. In previous example, we have seen we got a linear line and a graph, basically which is a continuous graph. Okay, and here we see how we plot the points on a graph. So question is why graphs look like lines or curves. Okay, so is there any criteria for that, or is there any method in which we can distinguish between how we can draw lines or a curve for a particular problem or a function? Okay, so let's learn. We have the multiple type of functions. So first is linear function. First we have a linear function. So in linear function, it basically produces a straight line. Then there is a same rate of change everywhere. Okay, you have the same rate of change everywhere. And it is very simple to draw, and definitely we can predict other values easily in the linear graph. So it is a predictable. So I want to predict any value, so I can predict it easily. An example is f of x, or we can also write as y, that is equals to 2x plus 1. So if we draw the graph for this that we have previously drawn, we see we got a straight line which represent it is a linear function, and every time it is basically the its rate of change any point is same. If I calculate here, and how basically we calculate the rate del of y on del of x. Okay, that is basically how we can calculate the rate of change. And we know it is very simple to draw and predictable. Basically, I can say if I want to see like what will be the value at x equals to 5, it is very easy to calculate what will be the output at x equals to 5, and we can easily predict our output. So linear function are the simplest one. Okay, then we have curvilinear functions. Curvilinear functions. So basically it produces a curve. What it produces? It produces curves, rate of change keeps changing. changing. These are continuous but not a straight line. Okay, these are basically continuous, but not straight line. So, basic, or the I can say the most important thing that we need to remember is that these are the continuous. Curvilinear functions are always continuous. Okay, but these are not linear. For example, f of x we are having that is equals to x squared. So how we can plot it? So it will be plotted like these. So we can see it is a continuous function, right? There is no breaks, no gaps between any uh like the curve, but it is not a straight line. So in this we are having the functions with two variables. So far we have seen f of x equals to y going to y, now but now we are having f of x and y that is defining z. For example, this example f of x comma y equals to 2x plus 3y. Okay, so we are having two independent variables. We are having two independent variables, that is x and y, and one dependent variable, that is z. Okay, if we want to visualize this, we need three axes. Okay, for this we need three axes, that is x axis, y axis, and the z axis. And we do not say we got a like a graph for this, and when we represent it with three axes, we got a plane. Okay, how we can represent this? So for this representation, for representing three axes, that is x axis, we are having y axis and z axis. We got plane, and the result will be in the three dimensions. And the important thing is to remember, no matter how many inputs we have, a function usually output a single value. Okay, we always got the one value for any function. Now next, talking about the summation, it's not like basically we are adding the two values or three values. In machine learning we have to add a lot of data, and for that we definitely can't use a manual thing, or we can't use pen paper, or also not the calculator is like optimal option. So how computer compute it? So let's talk about it. Basically summation means we are adding the things. Okay, so here we are repeatedly adding not the same thing but the data. So here we repeat something and add the results together. For example, we have summation from, sorry, we have summation from I equals to 1 to I equals to 5, that is 2 of I. What it means? Firstly, we will compute 2 into I and i's value is going from 1 to 5, and then we are basically adding the number. So repeat something means we are repeating this function and that we are adding the numbers. So how it will be, right? Like 2 into 1 plus 2 into 2, then 2 into 3, then 2 into 4, then 2 into 5, and we got the answer, that is 30, and the final answer will be 30. So this is how summation work in machine learning. Let's talk about the exponents. Okay, so exponent is basically when we add power to the variables. For example, it's x square, we are adding the power 2, x cube, we are adding the power 3. That is basically called the exponential. So there's that some rule when we are using the exponents. So there is a product rule. Okay, we are covering the everything. Product rule. So what it says? So if I am like multiplying x square into x of 3, what we will do? I have to add these numbers. So x of 2 plus 3, that will return x of 5. Whenever I am multiply two exponent values, I have to add their exponents. What will I get? X raised to power 5. Then we have the division rule. So what division rule says? So for example, if I have x raised to power 2 and x, what will I have to do? I have to subtract it. So what I do? X 2 minus 1. What will I get? X. We can also have the fractional exponents. Fractional exponents, like how we can solve that. Okay, like for example, I have 4 raised to power 1 by 2. What it actually means? Under root of 4. That gives us 2. Basically, it is a root, square root. We are calculating the square root. So let's take another example. We have 8 and we are having 1 by 3. So I am finding the cube root of 8. Again, I am getting 2. We can apply the multiple functions on a single number. For example, like having 8 raised to power 2 by 3. So what we are getting, we are firstly the squaring the number, and also here it is under root the same number. So what will I do? Under root of 8 raised to power 2. Then what will I get? Cube root. Sorry, it's not under root, it's a cube root of 8. It's giving me 2, right? And then 2 raised to power 2 give us 4. This is the method how we can easily solve the exponent value. Then we have the power rule also. What will we do in this? If we are having 8 cube raised to power 2, we basically multiply it. Okay. So what will we do? We multiply 2 into 3 and we get raised to power 6. So we're talking, can we have 8 raised to power 1.4 something? Like, can we have like this? So the answer is yes, these are valid. Okay. For example, if I did 8 raised to power 5, so it automatically take 8 raised to power 3.14, and on basis that we get some approximate value like this. That's the basic exponent that we need for the ML calculations. Okay. Then we have the logarithms. Basically, it is exponents in the reverse order. We can say exponents in reverse. So here we can ask 2 raised to power what power give me 8, right? So 2 raised to power what what that give me 8. Although we know if we write 2 raised to power 3 I get 8, but in some cases or in a big numerical value we don't know what raised to power what give us this value. So how will we compute? We will take the logarithm. Okay, so what we'll do, x equals to log of 2 of 8. Okay, and it will return us 3. Basically take the logarithm. Logarithm is used to find the exponent. It is used, you can used to find exponent. Okay, so it is very important in logic, logistic regression, lowest function, probability, and optimizations. So even in many many formulas, we use a logarithm. So logarithm plays a lot of importance in machine learning. So this is all about today's lecture. In this lecture, we have discussed about the functions, what functions are. So it basically take an input and give us some fixed output, or we can say every value give us only one output that we need to remember. Then we're talking about the continuous function. A continuous function are those functions which for which function for any two values it will give us a solution for every particular number that is present between any two values, and the graph of the continuous function will be smooth and it is unbroken. There are no breaks present in the graph. Then what is a graph? Graphs is basically a visual representation of the function, and here we plot the graph and we can see there is no break, so it is a example of the continuous function. Then we talk about the Cartesian plane, that now we also call it as a xy plane, and it is basically a 2D space. Now we having the two axes, x-axis and y-axis. Okay, then we talk about the linear function, basically types of function. Under this we learn about the two type of function, linear function and the collinear function, curvilinear functions. In linear function we see we always got a straight line and there is the same rate of change of values, and it is simple and it is predictable and the graph is smooth. In curvilinear, it produces a curve instead of the straight line and it is always continue and the rate of change keep changing. Then 3D graphs, here we have the three axes, x-axis, y-axis and z-axis, and and its representation is in a plane. We don't make any graph, we call it as an plane. Then we talk about summation. How we do summation? Basically, we repeat the function and then add the each result with the total final result. And here we see like we continuously doing the same function, repeating the same function like 2 into 1, 2 into 2, 2 into 3, and then we're adding each output to the final answer. Then we talk about the exponents. We know something when variable are assigned some power that we call the exponents. And there are some rules that we need to remember. First is the product rule. In this, what we do, we see x raised to power 2, or we are giving any product of the two exponents, we have to add their exponent values. For division, we are giving the two exponents, we have to subtract the values, and definitely we can have the fractional exponent. It will always give a result, and we are having it is a valid to have an fractional exponent. For power rule, if we give exponent of the exponent, then what we will do, we basically multiply these and we got some answer. Then lastly, we talk about the logarithm, and we know in machine learning, logarithm plays a very important role. In very simple formula or in very complex formula, we use a logarithm, and basically it is used to find the exponent. Okay, so for cases like we don't know what raised to power but give us some value, in that cases we use the logarithm. So this is all about today's lecture. In next video we are going to cover some basics, and then we cover some advanced topics that we need for machine learning. Okay, just if you have any doubt, just comment it down. Do like, share, and subscribe. Thank you.